Welcome to Senior Paris. So take your notes and your pen. Please don't just watch it. Put something down. Good. So you are still on core mathematics. The topic is variation. Very interesting topic. You will love it. You will love it. The objective for today is by the end of the lesson, you will be able to write direct variation in symbols, then solve problem involving the type of variations. That's all. Direct variation, indirect variation, joint variation, and partial variation. Okay, so this is what we are going to do. Variations. So variation, we are saying that is a relation between two or more quantities or variables in which a change in one quantity results a change in other. So a change in one quantity will result in a change in other. So let's go to our daily life. The speed and the time travel. So the car speed and the time travel. Good. So if we increase the speed, the time will reduce. Yeah, so if you are traveling from Accra to Kumasi and know that the time reaching there, the normal time is 4 hours. If you increase the speed, your time reaching there will reduce. But if you decrease the speed, your time reaching there will increase. So a change in the speed of a car will result a change in the time travel. Okay, so if there's a traffic on the road, it's likely that the time will reduce. Good. So that's for the car. And punctuality and academic grade. A student who is always punctual in school will not miss anything. So his or her academic grade will change. Okay, so a change in the punctuality will result a change in the academic grades. But if you are not punctual in school, your academic grade will decrease. Yes, so this is a type of variation. Okay, so please just be punctual. A chicken age and its egg production. A chicken egg and its egg production. So the age of the chicken, okay, will result a change in its egg production. Good. Okay. By the older the chicken, the smaller what the egg that the chicken will produce. So this one, even it results in our daily life, our human being, especially our female gender. Good. Type of variation. We have direct variation, indirect variation, joint variation, and partial variation. So you are going to take these one after the other. Good. Keep watching. Variations. Our first type of variation is the direct variation. Direct variation. Now, with the direct variation, this is the kind of relation that exists between two quantities such that an increase in one quantity cause an increase in another quantity, vice versa. So this is similar to like the proportion, ratio of proportion. Okay, good. So an increase in one quantity will result an increase in other. So especially we talk about the academic grades and punctuality previously. So we are saying that if you are punctual in class, your academic grade will increase. So increase in the punctuality will result increase in your academic grade. But if you are not punctual, your academic grade will reduce too. Okay, so this is a typical example on that. We talk about that one. So I have an example here. If 4 pence cost 4 Ghana cedi, okay, then an increase in the number of pence means that the cost will be more than what the 4 Ghana cedi. So if 4 pence costs 4 Ghana cedi, so if there's an increase in pence, the money will be more. Okay, but if there's decrease the number of pence, the cost will be less. So this is a typical example. So we let S be the pence and the Y was the cost. So in this instance, the cost of pen Y is said to be in a direct proportion to the number of pens. Okay, So the cost of pence is said to be in the direct proportion to the number of pence. So in simply, we put it as y is direct proportional to s. Y is direct proportional to s. So in mathematics, you write it like this: y is direct proportional to s. Okay, so y is direct proportional to s. Simple in mathematics. Now, you want to put it in an equation form. So if you want to put it into an equation form, you have to change the proportion. Okay, the sign here. Then after changing it, you have to bring a constant. So this is an equation form. So y is direct proportional to s. Let's put it in an equation form. So it will be y equals k. So you see, we just remove the sign and bring it equals k. So we introduce a constant. So if you want to remove the proportion from there, you have to introduce a constant. So where k is constant of proportionality or variation. Okay, so when k is our constant of proportionality or variation. Good. So the k that we introduce is our constant of variation. Now this is a typical example under direct variation on the graph. Okay, we're saying that an increase in one quantity will result in an increase in another quantity. So as it increase, then here to increase. Okay, as here increase, here to increase. So as s is increasing, y2 is increasing. So y increase, s will increase, y increase here, from here s will increase. Okay, good. So y and s varies directly, and here is the constant of variation, and what this is direct variation. So this is a typical graph for direct variation. Direct variation. Mathematical expression for direct variation. So we are going to learn how to put this in what? In the mathematical form. 1. Y varies directly as s. That is, we talk about this. Y varies directly as s. So in mathematics, it's like this. Y varies directly as s. That's it. So that's y varies directly as s. And we want to put it in an equation form. So you have to move the sign here. If you move the sign here, it will be equals. Then you have to introduce a constant or proportionality. So this can be written as y equals k s. Okay, so if you remove the variation sign here, you have to introduce equals k, a constant, because you have to put it in equation form so that we can solve it. Okay, where k is a constant of proportionality. 2. Y varies as the square of s. Yes, we all know the square of a number, right? So y varies as the square of s in mathematics is in this form. Y varies as the square of s. Then let's put an equation form. It will be what? Yes, good. Y equals s square. Very simple. So y equals ks square, because you have to introduce a constant where k is the constant of proportionality. Good. The third one, y varies directly as the square root of s, and we all know what the square root is. So this is a mathematical form. Y varies directly as the square root of s. Then we have to put in an equation form where we have to introduce the k's. So y equals the k multiplied by the square root of s, where k is the constant of proportionality. 4. Y varies directly as the cube of s. We all know cube, okay? So this is y varies directly as the cube of s. Then you put an equation form, y equals k multiplied by the cube of s, where k is the constant proportionality. Last one, y varies directly as the cube root of s. Everyone know how to write the cube root? Yes. So this is the cube root. So y varies directly as the cube root of s. So this is direct variation. So let's put in an equation form. variation. So this is direct variation. This will be our first example under direct variation. And solving variation questions, okay, you see there's always a constant in there. So we have to solve for the constant before going to solve for the find the actual question. Okay, so always solve for the constant. Okay, good. That's the K. So given that P varies directly as the square of Q, and P is 4 when Q is 2, find Q when P equals 1 out of 4. Solution. So this is what we are giving. P varies directly as the square of Q. So let's write that. You have talked a lot about those things. Yes, good. Let's check it. Good. P varies directly as the square of Q. Nicely. Then you put this one in an equation form. So if you put this one in an equation form, you have to introduce the constant. Okay, so it will be P equals K, then the square of what? Q. Good. And this will be our equation 1, where K is the constant proportionality. Okay, and K is the constant proportionality. So that's be our equation 1. So in the question, you were given P equals 4, Q equals 2. Okay, so when P equals 4, Q equals 2. So this will help us to solve for the K. So you can decide to make the K the subject, or you just do the substitution in there, then you find the K before you come and solve for the question. Okay, find Q rather. Okay, so from here, P equals 4, Q equals 2. So let's substitute this one into the equation 1. So this is our equation 1. So our P is 4, and our Q is what? 2. So we get this. Okay, so we substitute this one into the equation 1. Good. So we are solving for the constants first. Then from here, because 2 square, you know, is 4. So for the K, before you find K, there's 4 here. So you have to divide both sides by 4. You all know that. We want K to stand alone. So divide both sides by 4. Then your K will be 1. So if you divide both sides by 4, you get 4 on 4. Then your K is 1. Very simple. So now we know K. We know K. So now we are going to solve for the question. So let's put K into the equation 1. Let's put K into the equation 1. So this is our new equation. Okay. So let's put K into the equation 1. And our K is 1. So if we put in there 1 times the square of Q is this. Good. So then we are now going to find Q when P is 1 on 4. Let's find Q when P is 1 on 4. Good. So to find Q when P is 1 on 4, we just substitute this one into this. So now we know K. So this becomes a new equation. Okay, so just substitute this one into this equation. So P is 1 on 4 and Q. Let's make it 9. So Q is equal to P. Q square equals to P. They are the same. Okay, they are the same. So because I'm finding this, I can decide to make this one the subject, or you can do the substitution, then continue. Okay, so I'll take square of both sides, square root of both sides. So if the square root of this, square root of this, these two cancel, you will get this. Okay, good. Then we know P. P is what? 1 on 4. Yes, P 1 on 4. Okay, then root of 1. We did indices and logarithm. Okay, root of 1 is 1. Then root of 4 is 2. So you take the square root of each of them. Okay, so you get what? 1 on 2. 1 on 2. So here, therefore, when P is 1 on 4, then Q is 1 on 2. When P is 1 on 4, then Q is 1 on 2. That's how to solve for direct variation. Example 2 on direct variation. Yes. R varies directly as the key root of VIN. R varies directly as the key root of VIN. When R is 5, VIN is 1 to 5. Find the value of R when VIN is 8. So this is the question solution. So we are saying that from the question, we are saying that R varies directly as the key root of VIN. So in mathematical expression, it will be this. Very good. R varies directly as the key root of VIN. So directly as the key root of VIN. This is the key root of VIN, please. The key root of VIN. So let's put in mathematical form. So mathematical form, that's where you introduce the constants. Yes. So these are in our equation form. Rather, you put an equation form. R equals K. So if you remove this, you have to introduce the constant equals K. Very simple. Okay, if you remove the sign, introduce the constant equals K. So from here, you have to solve for the constant first. So you are given R equals 5, V equals what? 1 to 5. Good. So where K is the constant, so given that, you are given this in the question, R equals 5, V equals 1 to 5. Then we just substitute to find the K. Okay. So this, so in variation, I was saying that in variation, you have to first solve for the K, the constant, okay, to find the actual equation. So let's do the substitution here. R is 5, so 5. Then the V is 1 to 5. Yes. So this is just substitution. So anywhere you see R, just put 5. Anywhere you see V, just put 1 to 5 in here. Good. Now the key root of 1 to 5. Yes, 1 to 5. The key root of 1 to 5 and 5. You don't know. You can use the calculator to find the key root of 1 to 5 on your calculator. Okay. Good. So 1 to 5. Then the key root of 1 to 5 is 5. Yes, you get 5. Then 5 times the k. So here to refine for the k, then our k is 1. So you put k is 1 into the equation. That's the equation 1. And this will be our new equation. Okay. So we have solved for the k, and k is 1. Okay. Good. So now we are going to find the value of R when V equals 8. So now we are going to find the value of R when V is equal 8. So solving variation question, you step by step, you just express it in mathematical form, then you form your equation, then you find the constant, then you come and solve the actual question. Find the value of R when V equals 8. So when V equals 8, R will be what? You just do the substitution. The V is 8. The key root of 8 is 2. Okay, so you can use your calculator to do that. So therefore, when V is 8, your R, for direct variation. Another example, the third example and direct variation. P varies as the square of Q plus 1, and P is 2 when Q is 3. Okay, so write the equation connecting P and Q. Find the possible value of Q when P is 8. Very simple solution. So P varies as the square of Q plus 1. From the question, it will be what? Yes, P varies as the square of Q plus 1. So this is what they mean. Simple. We talk about this. Yes. Then you put this one in an equation form. Okay. So you just change the sign and it's equals K. Then you introduce the K, the constant. Very simple. Good. So you just do this, then change the constant. So this will be our equation 1, where K is the constant. Now, in the question, we are given P and Q, which will help us to know our K, the constant. Okay. So we are given P and Q. The P is 2, Q is 3. Then you substitute it into the equation. That's equation 1. Yes. Just the substitution. Now from here, 2 equals K, then 3 plus 1 square. 3 plus 1 is 4. Good. Then 4 square will be 16. Yes. Okay. Then we solve for k. We solve for k. Divide both sides by 16. You get 1 on 8. And that's for our k. Now then substitute this one into the equation 1. Yes. So this is what? Our new equation. So now we know for the k, we can solve the question. So this for the first question. Write an equation connecting P and Q. So this is the first I. Okay. So that's the I. Then the II, find the possible value of Q when P is 8. So from here, you say we should find the possible value of Q. So mean that we are given the P, so we should find the Q. Good. So our P was 8. So let's solve it. Let's make Q the subject here. There's a 8 here. So let's multiply both sides by 8. Okay. Let's get rid of the denominator. Good. So if multiply both sides by 8, so here times 8, this 8 will cancel. Then, okay. So then here 2 times 8, here times 8, then here 2 times 8. Okay, so it will cancel. This basic, you already know. Good. Then you have 16. That's this. Okay, 16 equals this. So we are to solve for the k. There's a square here, so I'll just have to take square root of both sides. Yes, square root of both sides. Then the square will cancel the square root because square root is 1 on 2. Okay, so it will cancel. Then we have this. So square root of 16 is 4. Okay, square root of 16. Okay, good. So then our q is this. Then we solve for the q, and this is our final answer. Very good. If our final answer for q. Direct variation. So we are moving on to our fourth example under direct variation. So this one will be in a table form. In the table below, y varies directly as s changes. So in the table below, y varies directly as s changes. Find the value of a and b. So you should find the value of a and b. Change y varies directly as s. Very simple. Y varies directly as s. This is the expression. Then let's put in mathematical form. That's where you have to introduce the k nicely. Then this is equation 1. Good. Now, where k is the constant proportionality. So from the table, I'll just choose one of these. So I'll choose 1 and 3, okay, to find k. Because we cannot find a and b, okay, without knowing the k. Okay, that's a constant. So as we are solving for the previous examples, we already find the k. So we are giving y is 1, then s is 3 from the table. Yes, y is 1, s is 3 here. Good. So substitute this one into the equation to find k. So you get your new equation. Then our k will be what? 1 on 3. Good. So from here, you just substitute 1 on 3 into the equation 1. So from here, now, this is our new equation. Now from the table, y is 2, s is what? B. So this will help us to get our b. Okay, good. So just do the substitution here. Y is 2, s is b. Good. Y is 2, s is b. Therefore, we are solving for b. So there's 3 here. Multiply both sides by 3. You get 6 equals b. Okay, good. Then b is 6. Okay, b is 6. Very simple. Now a, y is a, s is 15. So we can use our new equation here. So y is a, then s is 15. Good. Very simple. Then our final answer is 5. But 3 goes here, 1, 3 goes here, 5. So therefore, our b is 6, our a is 5. Very simple under the direct variation. Okay, so you see, during the direct variation, you always solve for the k before we come and solve for the actual what they are being asking us to find. Okay, subscribe to Senior Fellows for more videos. Good. We will continue with the inverse direct variation as part 2.